Connected by purpose, driven by passion. This is Children's Healthcare Canada's Spark Live webinar series.
Children's Healthcare Canada would like to thank our Keystone funding partners for their ongoing contributions that support all of our programs and activities, including this Spark Live weekly webinar series. Spark Live is where we gather each week to curate, convene, and showcase excellence and innovation from across the child and youth healthcare community. Our goal is to spark conversation, ideas, and action. There are two options to join in on the live conversation. Questions and comments for our panel or presenters can be typed into the question box, or comments that you want to share with the audience can be typed into the chat box and be visible to all of the attendees. For those of you on Twitter, tag @ChildHealthCan on any webinar-related tweets or use the hashtag SparkLive. And to keep up to date on all of Children's Healthcare Canada's webinars and other activities, be sure to sign up for our weekly Spark Bulletin by visiting our website at childhealthcan.ca.
Hello everyone, and welcome to another edition of Children's Healthcare Canada's Spark Live webinar series. I am Paula Robeson, your host for the next hour. Children's Healthcare Canada acknowledges that our offices, located in Ottawa, are on the unceded, unsurrendered territory of the Algonquin Anishinaabe people. We're grateful to have the opportunity to be and live in this territory. Today, we're delighted to bring you Imagine, complex genomic testing, keeping families at the core, with guests from Children's Healthcare Canada member and grateful for their support for the Child Bright Network. As mentioned in the intro video, please type your questions into the question box at any time. I'll prompt you via the chat as well, and we'll pose the questions to our panelists at the end of the session. Now I'd like to introduce our speakers. Colleen Guimont is a certified genetic counselor who currently holds several positions, including one at BC Children's Hospital as part of a study for whole genome sequencing in atypical cerebral palsy. At ChildBright, Colleen is a project team member of the diagnosis using integrated metabolic and genomics in neurodevelopment, or the Imagine research project. Patricia Birch is a researcher, educator, and manager with extensive experience in genetic counseling and nursing, including outpost nursing. Patricia has studied the efficacy of different methods of delivering genetic counseling and recently co-designed and implemented an online interactive multilingual decision aid to support families' whole genome sequencing testing choices. It's my pleasure to pass the mic to Colleen.
Good morning, everyone. Thank you so much, Paula, for the introduction. I am Colleen, as Paula said, and I'm a genetic counselor working with the Imagine study, which is ongoing at BC Children's Hospital in Vancouver. My colleague and friend Patricia is also on the call, and she will be presenting some of this work as well. We're presenting on behalf of all of the incredible families participating in this study, as well as on behalf of our parent partners, Kelsey, Brenda, and Isabel, who are so generous with their time and their insights. We have two students, Julia and Nicole, who have been instrumental with this study, and Dr. Jan Friedman, who's the principal investigator, who's very invested in these families as well. Next slide, please, Patricia.
I'm trying. This is exciting. Okay, let's try this. There we go.
There we go.
Perfect. So this is the reconciliation poll, which is on the campus of UBC, and I use it as a reminder to acknowledge that we live, work, and play on the unceded territories of the Musqueam, Squamish, and Tsleil-Waututh First Nations here in Vancouver, and we gratefully acknowledge their wisdom in keeping families at the core of our lives. So today we're going to walk you through an overview of the Imagine study. We'll start by reviewing the design and goals of the study and discussing how families move through the different stages. We'll provide you an overview of the results to date, and you'll also hear about some of the unique tools that we've been able to develop to support families through the process of genetic testing. So the goal of the Imagine study is really to provide insight into possible genetic or genomic causes which underlie atypical cerebral palsy. You may not have heard that term before, atypical cerebral palsy. We think of it as a group of conditions which have cerebral palsy or have major motor component as part of the condition, but they're atypical in some way. So that may mean that there are clues that would be more suggestive of a genetic cause in this child. What I mean by that is they may have a picture that doesn't typically fit with cerebral palsy. That may mean that there's progression of their symptoms, which we wouldn't typically see. It may mean that their MRI doesn't look typical, or that their birth history is not suggestive of a period with low oxygen. It also often means that there's another clue, either with the child or in the family. So sometimes these children in the study have a sibling who have very similar set of symptoms, or it may be that the child themselves has a complex picture that may be suggestive of an underlying genetic cause. So sometimes that means that in addition to CP, they have hearing or vision loss, global developmental delay, seizures. So I would say as a whole, the kids in the study are more complex and have a higher level of needs than a lot of children with typical cerebral palsy. So our plan was to enroll 100 families, consisting of at least one child per family with atypical CP, and both of their biological parents as well are required to participate and provide a blood sample for the study. So the aim then is to see if we can provide a specific diagnosis to families in the study. And in order to do that, we're using two different types of testing. So the first is called whole genome sequencing, and the second is called Metabolomics. And I'll tell you a little bit more about that in the coming slides. So whole genome sequencing is the most advanced genetic test that we have right now. In Canada, it's typically only available through research studies and not as part of clinical care. That's probably a cost issue. It's an expensive test to run, but it really does provide the most thorough analysis of the genetic code. Can I look at the next slide? There we go. So this is a schematic that we sometimes show to patients just to relay what we're doing. So when we say whole genome sequencing, what that means is we are actually looking at every letter of the DNA code, which means over 3 billion. So we get half of our genetic information from mom in the egg and half from dad in the sperm, and they come back together to make the kid. And so we're able to go through all of the information from mom and from dad and from child, and to see if there are any spelling changes in the DNA that would explain a change in a protein and that would subsequently result in a set of symptoms that match with those of the child. So sometimes you'll hear about different types of genetic testing. We have targeted genetic testing, where a geneticist will have an idea from looking at a child's history what they might have and can go and do a direct test looking for a change in that gene. And then there's a step down from whole genome sequencing called whole exome sequencing, where if you're looking at this picture, you can see that the DNA is divided up into these sections called exons and introns. So it's the just the exon code that is looked at when we're doing whole exome sequencing. And when we do the whole genome sequencing, which we're doing in Imagine, we're looking at the coding for all of the exons and all of the introns intervening. So it's a pretty thorough test. In addition, we're looking at the DNA of the mitochondria in cells, which is separate than the nuclear DNA. And we're looking at it in a bunch of different ways that typically don't get looked at. So it's a pretty thorough look for these families. And the second type of testing that we're doing is called Metabolomics. This is a way that we can look at all of the molecules and enzymes. Patricia, you could actually switch to the next slide. There's a bit of a schematic there. That's okay. So basically, this metabolomics testing is just happening on the children, not on their parents. The kids have to be fasting for this part of the blood sample, and it's a look at all of the proteins and enzymes and particle particles in their blood at one time so that we can look for patterns. Any patterns that are out of whack or levels that are too high or too low, we can use as a clue to figure out if this child has an underlying change in their genetic code. And so it can help us to look back at the DNA in a more careful way, in a more targeted way. And we can also use metabolomics. Hopefully the goal is down the road, if we're able to make a direct connection between a genetic condition and a biomarker or metabolomic change in the blood or other body fluids, then we can use that easier way of testing, like just a blood test looking for a protein level or an enzyme, to figure out what a child might have. So that's a goal, and so we're using both of these tests in conjunction in order to provide the most complete picture back to these families. I'm going to pass it over to Patricia at this point.
So why would families want to participate in Imagine? So here are some quotes from parents who are really able to say it much better than we can. And they point out the challenges of living not knowing what's happening to their child. A child that doctors can't diagnose is unnerving, and some families spend their whole lives seeking answers. Parents also say that a diagnosis ends what some people have called the diagnostic odyssey, which puts a stop to all the endless testing that's so stressful for all members of the family, time-consuming, expensive, and just exhausting. And it gives families a roadmap of what to expect for the future for their child, and sometimes for the other children in their family or for future children. Occasionally, but not often, it can change medical management or provide a treatment. And families also find that a diagnosis can help them to access services, and it can enable them to connect with others with a similar diagnosis or the same diagnosis, often via support groups or social media. But the Imagine study doesn't provide an instant diagnosis. Imagine is a complex multi-step study, and from the time of enrollment here to the time of provision of results, which is here, takes at least 6 months, often longer. And as you can see, there's a lot going on in between enrollment and getting results. But the families are often not completely aware of all these intermediate steps. And so without the understanding of these intervening processes, the waiting period is made even more stressful for parents. Waiting for results is tough at any time, as several parents have said. There's nothing like the black hole of healthcare waiting. We're kind of left in the dark. And we certainly knew all of this intellectually, but we didn't think to do anything about it other than repeating what we were already telling them. That is, we were explaining at the process of the initial genetic counseling appointment, which is already stressful. And there's a lot of other information to take in, and they're just not hearing all the fact that it's going to take 6 months and that there are various steps. But this all changed for us after one of the Imagine parent partners emailed a couple of months after her family enrolled in the study, and she sent this friendly message to me saying, "Good afternoon, I'm just checking to see if there's any update with my study." And I replied, giving her a ton of, really carefully written details about the study, being very conscientious and letting her know all the behind the scenes steps. And, after the blood is taken, it goes to the lab at the Children's Hospital where they extract the DNA and they freeze it and the second sample goes and all that blah, 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 right? And then I asked her if she thought it would be helpful for me to send that same sort of information to other families as a reminder of what was going on. I don't know where my head was at, but half an hour later, she replied with this instantly understandable graphic that she just whipped up. And she said, "You need something like a FedEx delivery bar." So as you can see, it visually traces the steps, the path of the DNA flying from Vancouver to Montreal and being sequenced and so forth. And this was the idea and the impetus behind what we now call pop-up, the FedEx timeline. And that resulted in our now emailed graphic communication that we provide throughout the study to all families. Our parent partners worked with our Childbright Summer Studentship Awardee Nicole Liang to convert Kelsey's idea into reality. And this is what the finished product looked like when it arrives in a family's email inbox. So here's pop-up, and it follows each family's route from blood collection through DNA extraction, sequencing, and so forth through to results. And this blue bar here moves along to show each family how far they've got. And each time the study status changes, they get another update with the blue bar moving along at the same time. And each graphic on the timeline has hover over definitions. So for example, if you were to hold your mouse over DNA sequencing right here, it would tell you further details as to how and where and why this is going on at that stage. And importantly, on this screen, there's also, for every single time they get a pop-up in their mailbox, there's a little reminder at the top right, which is too small for you to see here. But it says, as parents, you are experts on your child's health. Please contact us if their health changes. It might help us to interpret the results. So this acts as a constant reminder to stay connected and that it's okay to contact us. So we automated pop-up so that we could send out emails to families without a lot of extra work on our part, which was really important and great because obviously we hadn't planned to integrate this into our workflow when we originally wrote the grant. But what we immediately realized was that pop-up doesn't work for families who don't speak English. So, and fortunately, we were really easily able to translate it to the main languages we needed because there were genetic professionals associated with the Friedman Lab who speak these languages. And so we were able to immediately create simplified and traditional Chinese scripts, Punjabi, and Arabic. And we asked parents about the timeline and determined that it was quick and easy for them to use. And parents felt it kept them in the loop. And most importantly, from our perspective, the continual reminder to parents to let us know if their child's health changed actually contributed to a diagnosis in at least one family where an additional piece of information pointed to a genomic result. So that is really key. So what I'm going to do now is to turn this back over to Colleen to talk about the actual results to date.
Thank you, Patricia. So here's a bit of a graphic of the families that have been looked at for Imagine so far. So the families are referred to the study from many different specialists. So we have some families referred from the genetics department, from biochemistry, neurology, orthopedics. So because these kids are complex, they may have seen many different specialists. We also have a few families, I'd say 3 or 4, who have self-referred. We've had a few playground referrals of families who've met each other at support groups or literally on the playground, one of them, who found out about the study and were very keen to participate. So being referred to the study doesn't mean that they will be accepted into the study. We have quite strict triage criteria. So we've been through almost just over 900 or closer to 1,000 maybe by now, triaged families. What that means is that we are required to go through all of their medical records and review them with the physicians involved in our study to see if these kids have a different diagnosis, which would explain their condition, meaning they don't need to go through Imagine, or whether they truly meet the criteria for atypical cerebral palsy. So of all of those families who've been triaged, we have enrolled 106 families. This was as of October 1st, and we're now up to 108 actually. 11 of those families have been withdrawn. So sometimes that means, and I saw there was actually a question in the pop-up chat box there, sometimes that means that one or the other of the biological parents are not available. There are a few kids either where one parent or the other is either not willing or not available or or the children are in the care of a different family, so we're not able to access biological parents. And that actually is a requirement for the study, because some of these children have brand new changes that did not occur in either parent, and that's a huge clue in genomics that it's something to look more closely at. And so that we do require both parents to participate. So a couple of the other families have withdrawn because there's been another diagnosis in the meantime that explains their set of symptoms. So again, no need to go through Imagine. So we have 95 and now 97 families actively participating. That 95 families was made up of 84 trios, so a child and both parents, and 11 quartets, meaning both parents and 2 children who are very similarly affected, so thought to have the same condition. We've sequenced 88 families so far. So to sequence them means that we've put all of the letters of their DNA code in order, but that's only step 1. The real time-consuming part is to go through all of their genetic code, put it through all of our computer analysis, and then come up with a list of genetic changes, which we then need to go through each one and see if that may be an answer for this family. So we now have results for 81 families. We've not returned all of them, but we'll look at them a little more closely on the next slide. So what does that mean to get results from a genomic study? We may clearly find an answer, so find a change in the DNA code that would affect a protein that has been shown in in the scientific literature to cause a set of symptoms that are seen in this child. So a good fit. That is a positive result. So we have had results go back to many of our families, and they then have a name for the genetic condition that their child has. It also means that we're able to tell them if it's something that happened just as the child was made, so a brand new de novo change, or if it's something that was inherited in the family in following one of the genetic modes of inheritance. And that's important information for families because it allows them to know what the chances are for this to happen again in the family, and it gives information back to some other family members as well. Sometimes we go through all of this testing and we do find a change, and we are suspicious about it, but we don't have enough information to say for sure this is an answer. So that would fall into the category of uncertain. In genetics, you'll sometimes hear the terminology a variant of uncertain significance. So these ones we always go when we have either a positive or an uncertain result that we're suspicious about. We go to a second level of testing to confirm with another lab that the change is real, and to look at that lab's interpretation as well to see if they think this could be an answer for the family. So we do return these uncertain results to families, but it can be tricky, and it can require some patience as we wait for the scientific community to catch up with our ability to find these changes. We are still waiting sometimes for a bit more information to interpret them fully. So that can be difficult for families to just be waiting to see if we're able to catch up our knowledge with our ability to detect the changes. Some of those uncertain results, we have a clear path forward that we're able to collaborate with some other researchers and do a little bit more testing on that genetic change to see if we can get any clues of whether this is truly causing a change in the protein. So sometimes that means doing a test called an RNA test, or sometimes that means looking at the protein a little bit more closely. So we have 6 families right now who have uncertain results but are in the process of having a bit more testing. Sometimes we get a negative result. So that means that we went through all of the genome testing so far, and we're not able to come up with a change that we think is associated. It's a fuzzy ending because it's negative so far. What that means is that we are still learning. We are discovering new genes every day. We're discovering new ways to look at the genome every day. So not finding a genetic change does not rule out a genetic condition in the family. It just means that we haven't yet been able to identify anything. Of course, some of these families may truly not have a genetic condition. We're expecting that, but we also want to set that expectation with the families that a negative result doesn't rule out a genetic condition at this point. And we do continue to go back and look at these families. And in fact, even families who are enrolled near the beginning of the study period, we've gone back and looked at and been able to update across time as more genes are discovered and more papers are published. And then the last possibility that we discuss with families at results are incidental findings. So anyone who's been through either whole exome or whole genome sequencing may have heard about incidental findings. These are changes in the genome that are unrelated to the reason that the child was having any testing, but they are genes that could cause a health problem for either parent or children. And in addition, that there is a recommended follow-up treatment or surveillance for. So parents in the study have the option for themselves to find out if we do detect any incidental findings, would they want to know for themselves? And we have a good pre-test conversation about that. So those are things maybe like genes which would predispose to sudden heart problems or a high risk of cancer or an adverse reaction to anesthetic. So things that we would have a concrete move forward for family members. If there's an incidental finding in the child and it would affect them in childhood or could, we are obliged to return those results to families. So that's all part of the pre-test counseling and decision making, but sometimes we've seen a few families where we've had to return an incidental finding as well. So here's just a graph of the results to date. So if we take out those 6 families that we're doing more studies on, then we're left with 75 families that we have returned results to. Of those, 37 of them have a clear diagnosis from this study. So we're looking at about half of the families going through the study. And that's important because some of these children are young, but I would say a lot of them are teenagers. And so this has been an ongoing journey for these families to find an answer to the question why, and why does my child have this set of symptoms, and are there other families out there that we can connect with? So that's a really powerful thing to be able to provide that result to families. We have about 34 families that have a negative result to date, and those are the ones that we'll go back and look at a little bit more closely. We do have a couple of other ways to look at the DNA at this point, so they've been returned as negative so far, and the families know that we're going to go back and take another look. In that negative to date batch, there definitely are families who have a genetic condition. Just based on their presentation and based on the experience of the doctors involved in the study, Dr. Friedman especially, who's had a long clinical history in his career, is quite certain that we're stumped as to why we can't find it just yet, but definitely not ruled out as far as being genetic. And we'll advance the slide. And then as far as the metabolomics results, this testing is primarily being done in Europe, so in Netherlands and Germany. We don't have results back from this yet. We're batching all of the samples to send over, and all of the samples will be kind of compared to the other families, so that those results should come back to us kind of all in a big lump. So we'll be able to return those results a little bit later down the road. And then just to give you an idea of what families see when we return results. So this is an example of a report from a clinical lab. So as I said, we always get our research results confirmed by a second lab. The lab reports are notorious for having complex words and complex information. For people for whom English is a first language, this is very difficult because this is not typical English. But when English is a second language, that adds another layer of complication to this results return as well. So I am always present or try to be present when the results are returned. They're typically returned by the physician that referred the patient to the study, the family to the study. But it is a little bit overwhelming, and we do try to explain as much as we can, but it's hard to take all of that in at one time. But once again, one of our parent partners, Brenda, is on the next slide, contacted us to help us out with how we may improve in this area as well. So not in relation to the Imagine study, thankfully, this quote, but just something that Brenda had seen online when being on websites and chats about other families going through genetic testing, that the general feeling was that families felt abandoned and lost after receiving a genetic test result. So this may have something to do with that single in-person meeting to give results and with the lack of long-term follow-up. So we needed to create something to extend the support of genetic counseling past that appointment. So what our parents told us that, so this is Isabel and Kelsey, our parent partners. They guided us through some of the ground rules and told us, yes, we need information, but don't dumb it down. Don't take those words away. Just tell us what they mean. We need to know that vocabulary. Use lots of graphics to help us explain things. Make the information as specific as possible and not general, so that can help us even more. And make the language supportive. And so they further went on to tell us that they wanted some background information on the study, so more details about what we meant by genomics and metabolomics. They wanted the ability to have results personalized for each family so that they could pick up a resource and know that the information in there was dedicated to their family and specific. And they wanted to not have to Google the up-to-date resources specific to their genetic diagnosis. And that's important because there are several genes which, depending on the spelling change within the gene, will cause an entirely different condition. So just by giving the parents the name of a gene does not necessarily tell them the name of their child's condition. So we really need to be careful and be specific and be personalized in the information that we're presenting back to families. So that with the guidance of these parents and with the incredible, tremendous skill and energy of our Child Bright Summer Student awardee, Julia Handra, we designed the Genomic Test Results e-booklet for families. And rather than go through the contents in detail with you, we thought we would show you a 3-minute video of Kelsey, one of the parents, and Julia talking about the booklet.
Hi, my name is Kelsey O's, and I am a parent of a medically complex little girl. 4 years ago, when my daughter was born, I was abruptly submerged into medical jargon. And being in the middle of a traumatic scenario, I was not always accurately processing the information that I was receiving about my daughter. I would jot down the phrases or the terms that I didn't know, and I would take that back home and go to Dr. Google. This is a problem. The explanation of medical results and diagnosis about the child, my child I'm trying to understand, should be coming from the team who is working her case. And it needs to be in terms that I can understand if I'm going to have any luck understanding what kind of implications these results would have in my daughter's life. That's where this booklet comes in.
My name's Julia, and I've been working with Kelsey, the Friedman Lab, and other parent research partners to address this issue. Together, we developed a customizable e-booklet that offers digestible information, guidance, and support to families receiving genomic testing results. Genetic counselors or physicians can efficiently use the booklet to produce patient-specific content. When details about the results are filled in on the summary page, larger informative sections are automatically populated. Unlike a lab-generated genomic report, the booklet captures the clinical interpretation of the results. This way, the most meaningful findings are presented to families in a clear manner. The e-booklet can also be used in the case of a negative testing outcome. Here, genomic unknowns and uncertainties are introduced along with a possibility for reanalysis in the future. Once customizations are complete, the patient and their family receive an e-booklet that is made for them. The results are available in accessible language, and important medical terms are explained. Space is provided for note-taking, and the e-booklet also prompts physician-patient communication. The last section of the booklet guides readers in their next steps, which may include sharing their results, seeking support groups, finding social and financial resources, and more. This section can also be personalized.
With this booklet, there isn't going to be the need to turn to Dr. Google and have the potential to be receiving false information. The individualized, proper information has been given to the parent. This is what every parent who's trying to navigate this world is needing when they're going through genetic testing and receiving those results. This is what I wish I had for every test result my daughter has ever received.
Booklets have been customized for families in a genomic study. Preliminary evaluations show that the booklet reinforces clinical appointments, helps families share their results, and is viewed as a long-term resource.
So, as Julia said, we're formally evaluating the booklet through questionnaires and recorded interviews, but essentially you just heard a pretty typical reaction. So here are just two statistics hot off the press from her questionnaire responses so far. 23 of 24 respondents felt that the booklet refreshed their memory of the information given at that appointment with Colleen and their referring doctor. And 19 of them felt that the booklet will also help them to communicate their genomic testing results with other healthcare providers and other people like educators and family members in the future. And the families repeatedly said that they would return to the booklet and refer to it as they needed. So parents say that the results e-booklet does everything it was envisioned to do, and that's fabulous. And this is the whole advantage of parent-initiated co-design, which really goes a step beyond typical parent-oriented research. If the ideas and the concepts and the guidance come from the parents, then the resulting co-design model ensures the best fit between what we healthcare providers think is needed and what is actually needed. So this all sounds great, but we're always asking how to break down barriers to accessing resources like Pop-Up and the results booklet. And language is certainly one very obvious barrier, and we're hugely grateful to ChildBright's Connect funding that allowed us to translate the booklet as well as to make some other adaptations to it. But beyond language, we need to ensure that all of Imagine's family-oriented resources can be used for as many families as possible. We know about some of the barriers to access. We know about health literacy. We know that not everybody has high-speed internet, and we know about language and cultural issues. And these we may be able to overcome, but there are undoubtedly many barriers that we're not aware of, or we're aware of them, but we don't know how to overcome them. And we're certainly only too cognizant that the people who may need the most support in healthcare and in research studies like this may well be those that we never hear from. And in ChildBright, this, at least to us, is the biggest challenge in family-oriented research. So we just want to leave you with these thoughts. That however well we think we're doing, we need to keep these questions at the top of mind. How can we identify barriers to access? How can we reach out to the seldom heard? how can we promote equity, and how do we reach people who are not the ones, like our parent partners, always putting their hands up. So maybe what I'll do is, after our acknowledgement screen, maybe what I'll do is I'll go back to that, and hopefully that slide can be a source for our discussion. So as Colleen said at the beginning, we have very many participants who've given us a tremendous amount of their time and energy in giving us information, in supporting what we're doing, and frankly, in telling us what to do. And our many colleagues in the Friedman Lab, and of course, Jan Friedman, the PI, for his contributions and support of parents' co-design for all the support materials we make. Thank you for your attention.
Thank you both for a great presentation. We've had some questions already typed in, and this is my cue to remind you all to just type away. I've been nagging you in the chat box as well. Sorry about that. So Doreen asks, have you ever come across a case where paternity of a child came into question, and she recalls a similar example in her practice where she had to deal with that delicate issue?
Do you want to take that, Colleen?
Yeah, so that is always an issue when we're doing trio or parent-involved genetic testing. That's part of the pre-test counseling, that non-paternity and or they call it misattributed parentage will not be revealed back to the family. So if we do come across that, it can make interpretation difficult. Sometimes no, sometimes we have a clear answer just from the genomic results from the child, but that's always an issue in a genomic study for sure.
Thank you. Wade asks, how does the Imagine team manage pardon me, changes of non-clinical significance, the ones that are not supposed to cause clinical issues?
I'm not sure I understand the question.
I'll ask Wade to type into the question box any clarifying comments he'd like to make for that question. In the meantime, I will go on to the next question, and Wade, type away. Richard asks, have you encountered cases where the molecular diagnosis reclassifies the diagnosis from, in quotes, suspected CP to something else, like HSP or DRD? And have there been any unexpected negative outcomes as a result?
So we find that sometimes the term cerebral palsy is not used as specifically as maybe it's meant to be, or maybe what I mean is it is used to describe a constellation or a spectrum of conditions. And so we have had cases in Imagine where the child meets criteria for cerebral palsy, but in the end has had a diagnosis which proves that, yes, they've got some type of cerebral ataxia or a different type of condition which has overlapping symptoms. So, so that then we get back to what does that genetic diagnosis mean for the family? Does it change any management? Does it give them more information?
Thank you. Wade has clarified. Thank you, Wade. How do you engage with parents when it's a genetic change of non-clinical significance?
So we're not really returning ones that are not clinically significant. Some of them are. So whenever we go through the genome, we always find many changes. So when I say changes, what the programs are doing is really comparing the genetic sequence to, and I'll use air quotes, normal, or what we expect to see in that sequence. But it's very common to find things that don't occur on that list of normal. So then it's the job of our team to go through and decide which of those variants may be clinically significant. If we determine that the variants are not clinically significant, we do not return them. So they're just considered a normal variation. And that's not something we confirm with another lab, and it's not something we return to the families. It's just a normal variant. If we decide that it could have clinical significance and we're suspicious enough about it to confirm it with a second lab, then we do return them to the families, and in that context of uncertainty, and they know that going in. That's all part of the consenting process and pre-test counseling, that they may end up with an clinically uncertain result at the end.
Thank you. Christelle A has given you a shout out. Love the results e-booklet without autofill, so great job. And what's the estimated timeline for the results e-booklet to be made available to other healthcare providers?
Do you want me to take that, Colleen?
Sure.
Yeah, so at the moment, you will be glad to know that we're, thanks to the KT Connect grant, we have made some adaptations so that this research booklet, which was originally designed for the Imagine study, is more general. So, for example, we have included whole exome sequencing, which is not used in the study, but is used clinically as something that needs to be explained by the booklet. And we are right now in the process of introducing it into the medical genetics clinic, so for clinical usage. And we will probably test it there for a little bit, and then when we're happy with it, we can provide it to anybody who wants it. I think that's fair enough to say. But we're still testing it, and that's a really important part of research. We need to make sure that this is doing what we think it will do. We've tested it with a very small number, 24 people in a very specific study. So we need to see how it will perform, more air quotes, in actual clinical use. Does that answer the question?
It appears to me, but if it doesn't to our poster, please clarify in the box. Richard asks, is there a reason for the sequencing to be done in Genome Quebec instead of, say, the service in Vancouver?
Do you want me to take that, Colleen? When we originally applied for the grants, it was, to be honest, it was purely a matter of money, where we could get it done well and cheapest, because it's a very expensive test, and the sequencing is a large proportion of the budget. So it was just purely economics at the time.
We often make those kinds of decisions based on resources and economics and other factors. Wade wonders if there's a link available to where they could access the PDF, and if there is, perhaps one of you could type it into the chat box.
For the results booklet?
Yes.
It's not ready for wide use, I don't think, just yet. We're still trialing it with the study population and then onto a few other clinics, but that's definitely a plan for the future. I know that it's definitely something parents are clamoring for, and I was just looking on the Twitter of another family not involved in the study, but saying that he had posted his own guide on how to interpret a genetic testing report. So I know that that's definitely something that parents are looking for, and we're hoping to get it out as quick as possible. Patricia, do you have anything to add to that?
No, I think that's fair. But it's not just families that want this. We're also seeing clamoring amongst our neurologists and biochemical geneticists, all really interested in using this resource.
Wonderful. Good to be filling a niche or a gap in the information barrier.
Well, I think it's going to get more and more common as genetic testing is being ordered more and more, and that interpretation piece is tricky. So I think anything we can do to streamline that, to make the information accurate, is going to be helpful for busy clinicians and for families as well. And I loved the importance that was profiled through your work of the parents as a key to appropriate knowledge translation. It is vital to be responding to the needs of parents in that regard. Absolutely. Sandy has asked, with such rare genetic conditions, are these results being shared internationally, or do you draw from other international sources to help educate families on their child? Yes, so the study will be published. The labs that are doing the confirmation testing for us also have databases of variants that we're seeing. So this information all will go back towards helping the bigger picture and the wider world for other families. You're right that these conditions are very rare. So, even though all of the kids in the study have, meet the eligibility criteria, they're so variable in their set of symptoms. We've really, I think, only had 2 families with changes in the same gene in the study, and all of the other families have a change in a different gene, many of which are brand new changes that we've never seen before. So it's definitely going to add quite a bit to the literature in this group of families.
Thank you. And Richard asks, are your bioinformaticians and genomics interpretation teams looking at copy number or structural variants, expanded tandem duplications, etc., as well as single nucleotide changes?
Yes. Yes, so we're looking at all of those. So we're looking at structural variants, single nucleotide variants, deletions and duplications, short tandem repeats, mitochondrial DNA. So they're getting the full meal deal. The best tests we have, our bioinformaticians are in-house at BC Children's. They're excellent, and they've developed different pipelines and different ways to look at all of these different types of DNA variation that we can see, and that's a whole other aspect of the study, is that we're contributing to the analysis, and the technology of analyzing these families is improving as we go.
Thank you. Wade has also commented he did a whoa with negative and probable results being close in quantity, and due to the negative and probable counts being close, is specificity an issue? And in brackets, he has the AUC.
No. So, yes, we're...
Sorry, there you go.
No and yes. So these are all families who have, for the most part, have had lots of investigations. So there will be families who never made it to the study because they had investigations before. So these are really families that have been mysterious as far as the cause of their child's condition. So we are able to diagnose so far about half of those families who may have had extensive testing, including whole exome sequencing, before they got to this point with no diagnosis. So are we hoping to diagnose all of them? Yes, of course we are. There are going to be families in there who don't have a genetic condition. They just don't. So their child's condition may have been caused by something environmental, teratogen or an exposure during pregnancy, a stroke in utero. So there are lots of things that wouldn't fall into that genetic category, so they would truly be negative. But what we're expecting is that some of those negatives will, in fact, switch over to the positive causal or probable category as our ways to look at the DNA get better and better. So we're not worried about specificity because, when we have, specificity, I always have to review that one. Negativity in the absence of disease, is that it? Somebody jump in. I think, so we are, if that's the case, then we are worried about that. That's just probably part of our technology catching up.
And from an anonymous attendee, do you expect genetic testing like what you're doing with Imagine to continue after your study is completed? And a follow-up, is there space for this genetic sequencing in healthcare?
Genetic sequencing in healthcare is getting more and more and more and more common. So 2 parts to the question. So do we expect this to continue after? If we have funding, we will continue on with these families. All of the negative families deserve to be well worked up until we're quite convinced that we can't find an answer for them. Funding is always an issue, and time is an issue. It takes a long time to do these types of studies and go through all of the DNA code. And then, sorry, I forgot the second part of the question. Was sequencing in healthcare. So, yes. So more and more, the genetic testing companies are offering either panels or sequencing specific to conditions. So if you have a child who's got epilepsy, for example, then you can order genetic testing looking for genes that cause epilepsy. So that's that type of testing, or heart conditions, or intellectual disability. That testing is becoming more and more common. So definitely we're going to see that just explode in the coming years.
And many of us are new to co-design with patient partners and family partners. Do you have any advice with regard to the co-design of materials that you'd like to share with others?
I think the most important thing is to listen and to let parents lead. We have expertise in genomics. They have expertise in their own lives, and that's what the co-design is all about. It's amalgamating those two. And it's got a fairly decent literature. If somebody's wanting to look up co-design or look up experience-based co-design, that's the sort of jargon. But I think that's the best advice I can give. And someone's welcome to contact me later if they want any specifics on references for that.
And I always tell parents, it's not lip service. They are the expert in their child. They are the only one who knows every in and out of their child's health condition and journey. So, and these rare conditions, it might be one tiny little thing that tips the balance, because the way that we look at the variance really is, it's quite automated at the start of it. So it's a filtering sort of system. And if we miss the right word, one of the variants that's important in that family may be filtered out. So if we didn't know that they had a cleft lip and palate, if we didn't know that they had a seizure history, those sorts of things can be really important. So we always tell parents, yes, and there's that pop-up update, but please reach out to me if anything changes, if you have new information that would help us to look at this a little bit more closely. These are really rare conditions, so it's we very much count on the parents as experts and co-investigators.
Well, that's the end of our time today. Thank you, Colleen and Patricia, for sharing your time and expertise with us. Thank you to all of our members and other attendees for spending this time with us. We hope you depart with some practical knowledge to bring back to your organization. We have a packed fall Spark Live webinar schedule. Join us next week on November 11th at 11:30 a.m. Note the change in time from our usual 11 a.m. Eastern start, so it's 11:30, for a new medication algorithm for individuals with fetal alcohol spectrum disorder. As well, we invite you to join us for our annual conference taking place virtually on November 16th to 20th. And to register, visit our website, childrenshealthcarecanada.ca. It's always great if you can watch live, as your questions and comments really enrich the discussion. But if you can't, the recordings of these sessions are made available after the fact on our Knowledge Exchange network. So thanks again for joining us today. Thanks to Colleen and Patricia for this presentation, and to ChildBright for supporting our webinar program. And hopefully we'll see many of you back here next week. Bye, everyone.